Alright, so now let's start where we take a look at arithmetic and bitwise operations. So now let's go straight to the code since this chapter doesn't really have any theory that we're teaching using our PowerPoint slides. So we're on code number 6, arithmetic and bitwise operations. So just click this file and bring up our IPython notebook, and here we go. So now the arithmetic operations I'm going to teach you basically pertain to this function right here, cv2add. Now, what is important about this function is that remember when we were adding brightness values, I should say, to RGB image? Remember we were maxing out different colors? So what we're going to do, I'm going to illustrate the difference between using the cv2add to add brightness to an image, as opposed to using regular matrix addition here, which is supported in Python, to add brightness to an image. So firstly, let's create a matrix of 100. So what we're going to do, we're going to add 100 to all the values here. These are hundreds. Remember, we're adding this to all our values in the image. So we're going to use a grayscale image here. That's what the 0 is about. We use the 0 when we're using imread to load an image as a grayscale. So remember, if we're adding 100 to every value in our grayscale image, you're going to make the image much brighter. So let's take a look at it. So before we look at the second one here, hide it. This is exactly what you expected. You expect a very bright image like this. That's what we have done by adding 100 to every value here. And a lot of it looks white because it's reached 255 and it's maxed out. Now, what happens when we actually don't use our cv2add function? It looks like this. Now, what is this? Why is it looking so different? So let's put them side by side and I'll tell you why. So when you use cv2add values here, remember, let's suppose a value was say 200 and you're adding 100 to it, you're going to get 300. However, 300 is out of the scale of that 0 to 255 value we're looking for in our RGB image. So what happens if you get a 300? Now, what we want to do when you get a 300, you're basically telling it it's a super bright value and it just exceeded 255. So cv2add caps the value at 255. That's why it's all white. However, when you add it regularly and you get a value of say 300, what OpenCV is going to treat it as, it's basically going to treat it as in going over the 255 and starting back at 0. So you're going to get 50. So it goes over the 255, so technically 45 actually. So 300 really represents 45 here when you use regular addition. So cv2.add caps it at 255, which is why this one looks so bad and this one doesn't. Simple as that. And all of this code is just to illustrate that very simple function here. And similarly, there's subtracted with cv2.subtract. You take a look at it here, and it works perfectly as well. All right, now what would have happened? Let's, instead of doing added here, let's do a subtracted version here. So let's minus it now. And let's call this added 3 to avoid any confusion. And let's take a look at that. So look how bad this looks. Instead of having a dark image, what you want, you're getting some sort of weird dark and white image here, which is not at all what we want. So that illustrates here our arithmetic operations here. So now let's take a look at bitwise operations and masking. So firstly, before we do this, let's create some images here so we can actually demonstrate bitwise operations and or so and not. So we're going to create two images here. One is a square and one is an ellipse here, using our cv2 functions here. So I'm not going to go too much into this code. You should be familiar with it from before. Although ellipse may be new to you guys, so we can just take a look at ellipse here. And it's a good exercise for you guys to look at the official OpenCV documentation to see how the ellipse function actually works. So now, forget about how we made these images. Now let's actually use those images here. So bitwise operations are functions that, how do I describe this? The best way to describe it is they look at how images interact. So binary images, we're going to input into this, and how they overlap. So if you want to get the regions that they intersect or don't intersect, or they both intersect or they both don't intersect and everything else, you can actually use these operations to get those regions. So instead of talking about it, it actually is better to always play with these functions and use them so you can take a look at what they do. So, AND operation. Now, if you've done any logic in mathematics or computer science before, you know an AND operation basically takes where both of them are true. So remember, operations takes the square and the ellipse and highlights white only where they intersect here. So this is only where our square and our ellipse intersected. So you can see it better here. You can actually see OR is where they both exist, and so an overlap as well, so everything else. So that's why you can actually see the AND, which was just basically being this region here before. That's what this one is. So now let's look at XOR. So what is XOR? So XOR is everywhere where they both exist. It's not included, but they exist here and they exist here. So it's the opposite of an AND, technically. And now, NOT. NOT is not related to the others here because there's only one input into NOT, and it's everywhere that is not here. So it's a bitwise operation, and it's quite a useful bitwise operation when you want to invert things. So I actually have used this function a lot when I was inverting different data sets for my machine learning algorithms, training data. So you can use this quite often if you just want to flip all the ones to zeros and zeros to ones. So those are the bitwise operations here. So demonstrated that. So now, we can summarize what we learned in this video, the practical video. We've learned how to use CV2.add and subtract and how they differ from just adding values to your images to improve or decrease brightness, or I should say increase or decrease brightness. And you've learned to use some bitwise operations and/or and so. You've demonstrated how they work with the ellipse and our square, and how to use the NOT function to do a bitwise inversion of the image. So now let's move on to the other chapter, which is blurring and sharpening of images. Thank you.